Good morning to all dear students. Welcome to our another lecture. In this lecture, we are going to discuss about the special theory of relativity. In the topic, we are going to discuss about time dilation. So, what is meant by time dilation? Before discussing about the time dilation, let us discuss what we have discussed. Actually, the basic fundamentals of special theory of relativity. In the last class, we discussed about the Lorentz transformation. The Lorentz transformation basically will explains about the new space frame of reference. Before that, we have considered that velocity of light is absolute. Means the velocity of light is absolute. Means we have considered that everything is absolute frame of reference. Understood? So due to that, what happened? Galilean invariance, where velocity, everything is remain change. But here what happened when Lorentz transformation is applied, where velocity of remains constant. But in the other Galilean transformation, what happened where all the quantities, whatever the quantities like position, velocity, or frame of reference, everything is unchangeable, everything is absolute. But here what happened in the Lorentz transformation, everything is under a motion. Why? Why we have neglected the absolute frame of reference? We have neglected the absolute frame of reference. Whereas position, velocity, time, everything is changing according to the special theory of relativity. Basically, the two concepts we are having, the velocity of any particle or any substances or in material moving with a constant velocity in inertial frame of reference. Means any particle if you are trying to see or any system or any frame of reference if you are trying to consider they are moving with a constant velocity in where in only non-accelerated frame of reference. That is called the inertial frame of reference. And second one, the velocity of light c is equal to 3 into 10 power 8 meter per second is constant in all inertial frame of reference, whether accelerated whereof non-accelerated does not take any consideration. Sir, why you have taken this difference? Because here the light velocity. So Michelson-Morley again we are discussing why, because Michelson-Morley experiments have changed everything in the picture. To do this Michelson-Morley experiment only, we are able to get what? We are able to get the foundation postulates of special theory of relativity. Otherwise, it is not at all possible to develop the special theory of relativity. Understand? Like that, everything, if you try to see the difference between the Galilean invariance means unchanged, everything remains same. Whether you are in any frame you are related, it does not change. Whereas Michelson-Morley came to the existence, what happened? He said that velocity of light is constant. Understood. We doesn't got the finish. I will not discuss more detail because enough we have discussed in the that theoretical part of our class in the lecture. But my point is why we are discussing because it is related to the time dilation. Everything is interconnected in the our topic, special theory of relativity. If it does not understand even the Lorentz invariance or time dilation cannot be understand. So where a Galilean invariance is that is the law. And another thing we should know that Lorentz transformation. What is Lorentz transformation? We know very well. Where everything is in motion, only light is. Next, we got the before Lorentz transformation, we got the concept that is nothing but the two concepts of the special theory of relativity propounded by the Albert Einstein in the year of 1905. Now let us discuss about the time dilation. What is meant by time dilation? So the time dilation. So the name itself indicates what does it indicate? Time delay. Time is getting delayed. How it is possible? How to get the time is delayed? How we can say means we will try to know now. Here what happened here is nothing but time is getting delayed. How it is delayed? Let us see the some 4 or 5 examples I will try to explain that we can able to know what is actually happening. Why this idea is got actually? Why it should be delayed? Understood? So why it is taken? So examples, some examples if you try to explain, then we can able to understand. Example for that. So we already discussed. Suppose the train is moving. Before train moving, let us discuss about the Albert Einstein. Albert Einstein was the basic proposition or propounded the special theory two theories. But before Albert Einstein, Newton was there. Albert Einstein was very much followed to the Newton dynamics. But when he is trying to see the difference in the nature, he is trying to see the velocity of particles, universe, Milky Way. He is trying to study different observations of the planet. Then what happened? It is not able to come to the conclusion. What is happening? Why it is happening? What is the reason behind it? It does not able to explain based on this phenomenon. There is nothing but the Einstein based on the formulas of the Newton. Newton first law, second law, third law. So when the body is moving under the constant or a uniform motion is up, when it is moving very fast, it is does not able to apply. First example, we could try to see how we are going to get time. Time is getting delayed for what time when it is not considering as a what accelerated frame of reference. In non-accelerated reference, all are same. Understand? A train is moving with what already we discussed. Just to remember to time is 60 hours. Another train is moving here. Frame of reference. Whatever the frame of reference we are taking. Train here 1 and train 2. We are trying to here what happens whenever that persons are moving and we are seeing from the platform. What happens? We are trying to see a person is playing inside. A child is playing and throws the ball, and the ball is coming in the parabolic path for the person in the platform. But the person is seeing from the train of opposite 60 kilometers per hour, and this train is also moving with the 60 kilometers per hour. From this respect to both, what happened? Both are rest. Both are rest. They can see each other. They can see each other now because both are moving the same. But for platform, you can see that is a parabolic. Parabolic. Understood? And whereas the person which are in the opposite train or better in the opposite train, you see that it is in straight line. It is in the straight line moving. Understood? So what is happening here? That two frame of reference. The person which we are trying to see here, what we are trying to see here, that it is moving with some constant velocity. Some constant velocity it is trying to move. Another is moving in the straight line. Understood? It is moving in the straight line. It is trying to move. Another is moving constant. So what is happening? The person which is standing here outside of the platform, you see that is parabolic, like this. But the person here will see back straight. The ball is throwing like this and catching like this. Understood? It will happen. So it is going in this way, coming back for both opposite, moving with the same speed. And those here to here, those who are watching, it is getting parabolic. So what is happening here? What is the fundamental thing is happening here? And first point. Second point, time delay. How this time is reading the person which is going the 60 kilometers per hour and the train is moving opposite with the 80 kilometers per hour. Example 1 80. What happened? The person which are moving in the train 60 kilometers per hour is moving nearly faster, which are compared to the platform. So for them, in 50 minutes, he can reach to the another station, which is 200 kilometers. And the person which are going the bicycle, suppose we consider the bicycle, then what will happen? Then definitely we are going to see some sort of differences. The bicycle is 200 kilometers, it takes nearly 8 hours, 4 times larger. So here we are going to get some differences. What differences? We will know that is called time is getting delayed. But time is getting delayed for whom here? The time is getting delayed for the train, the person which are moving inside the train, the time is getting delayed because whatever the time is taken to duration to arrive the destination, is actually it should take 6 hours by bicycle, but he is reaching the 1 hour. So more fast 5 hours minus if you do for the bicycle ride, or if you consider a two-wheeler. So there is a difference because it is driven speed. So like that, if you consider the speed into the consideration, then we are going to see the time delay. Example number 2 and example number 3. Einstein was standing and the dark. He saw that light is coming and falling. Not light, it's from thunder. That the thunder is taking same time to reach whatever the thunder is taking place. It is going to reach at same duration of time. There is a no delay. There will be a no dilation is going to take place here. Why? That's why if you try to see sunshine, when cloud thunders or thunders take place, the sound we will listen afterwards. Light will travel faster because the speed of light is 3 into 10 power 8 meter per second. So it can travel about faster. Light 330 meter per second. That's why first lighting will come, then the thunder sound will come. Understood? So there is another phenomenon we should know. So here we see that the light travel, whatever the thunder taken from here, both are reached at the same time. Understood? If this distance is more and distance is less, we thought that a lesser distance will travel more. Both have taken same time. First example, and the person who are going inside the train also, he are able to walk the same at the same. No difference because he is moving with the 80 kilometers per hour. 80 kilometers per hour. Still, what will happen? We are able to see faster. He is moving faster. You should see time. He is moving away. He is moving away, but he is near to the light. He is near to the light. Another near the person is moving away from the light. Then what will happen? He should see that light will be getting delayed here. But it is not happening here. The light is not getting delayed. Actually, they are happening that light is not getting delayed. Rather, it is taking some more time. It is not at all possible. Rather, both have same. The traveling rate is 60 kilometers. It is exactly opposite pictures are getting because light is does not depend on any frame of reference, whether inertial or a non-inertial frame of reference. Everything is same for the light. So now the overall explanation is what here we can able to see that time is getting delayed. Faster we move, slower the time. Exactly opposite. Slower the time, faster the move. You can take faster the move, slower time is getting delayed. So like that overall what we can understand the detail, time is getting delayed. Slower the time, faster the moving. Move is faster means what happens? A ball is taken and thrown back with a larger speed. It will bounce back within 3 seconds. If I am applying lesser force, then what will be taken 4 seconds. Faster the move, then lesser the delay. So time is directly or inversely proportional to the velocity. Increases, time increases, velocity increases, time decreases. That is a very important aspect we should know. That's why we see we will take definition of speed. Speed is what? Displacement by time. Understood? Speed increases, distance increases, and time is getting reduced. Understood? That is a way. Even bikes or car, if you are traveling from here to some other districts, like you are going from any temple, what will happen? It will take some time to reach. Whether by plane, it will take time. The person who is traveling through the uh, through the plane is delayed. Time is slower for them because it's traveling faster. Understood? So depending on the frame of reference, we are able to get this all this concept. We should understand in this manner, in this criteria, otherwise we cannot able to understand anything. Understand? So now let us know more about the definitions concept. You please try to note down the key points. I will enter into the definitions and concepts of the book. Now let us see the now mathematical derivation. Now just now we have discussed about the concept. In relativity, what will happen? We can define the difference between the time. So time dilation is nothing but difference of time. Difference of time. Understood? Difference of time between the board between elapsed between difference of time elapsed. Elapsed means what? One delay of any two events when we are taking to the concept. Let us consider now the two events. We are going. Here one frame of reference I am going to draw. Another frame of reference I am going to draw. X, Y, Z. X, Y, Z. O is the source. S and S dash. Origin, not source. S and S dash. At time interval t and time equal to t dash. When event occur, when event. Understood? Here we are going to calculate the difference of time between the two incidents, where the object is at stationary position and the object is moving the cause. We have discussed in the Lorentz and Dilation transformation. So now what is going to happen now in relativity? We very well know can we define difference of time between two events measured by the observers related to each other. In other words, dilation is the length and interval of time. Time dilation means itself to the length and interval of time. So and another idea we can also two events which are measured. Two events which are measured with the observers. Two events which are occurring observer. Two events which are measured by the observer moving relative to each other. Just now we have discussed relative to move other means we are taking two opposites. Two opposites we are going to take into the consideration. That is the first point. Now consider the two frames S and S dash are the two frames. What is S? S is at rest position and S dash is under motion. S and S dash. S is under movement and S dash is under the motion. Understood? With a uniform velocity v. With a uniform velocity v. Uniform velocity v. At time t and t dash. Please note down t and t dash. Now we are trying to draw the expression. What does that expression will explain it? Time lapse. Delta t equal to t2 minus t1. So what is delta t1 and t2 dash if I am writing on? We don't have to exaggerate here much more. So the time taken by the observer is t1, rest position, and time t2 is nothing but the difference of time between the two events after it is moving. Understand? So what happens if you do the difference between the two? We are going to get how much amount of the time is getting absorbed. Understood? It is considered the equation number 1. Understood? Delta t equal to t2 minus t1. Another equation what we are going to take now, we are going to take the similarly duration of light pulse absorbed from the frame. Now the light pulse absorbed from the frame. Delta t equal to t2 dash minus t1 dash equal to equation number 2. Understood? It is the difference between the two events which were occurred at the regular interval of time. So now equation number one, equation T dash represents change of the, it is related to the S mark, it is related to the S dash coordinate axis system. Now what happened, what we are doing? Now we are doing the difference. According to Lorentz equation, we very well know. Now we are going to distribute. That is nothing but what is T1 and what is T2 dash. Then we can able to get the difference between the two equations. Understood? Now by applying Lorentz transformation. Lorentz transformation, we are able to get what is T1 and T2. So I am directly writing whatever the equation is to is there. Apply, we get difference of two. That is nothing but T. T is the what? T is the time. Understood? T is the time. T2 minus dx by d square under root 1 minus d square by d square whole power. So in middle we are having what? We are having the minus sign. We are having the minus T2 minus T1 minus to minus we are going to take place here dx by T1 T2. So overall we are getting 1 minus d square by d square is the general equation we are having. Now what happened? Minus to minus plus we are having the equation overall we are having. So this time is getting cancelled. Delta t is equal to T2 minus T1 under root 1 minus d square by c square. We are going to get this equation. Understood? What is that? Delta t is equal to T2 minus T1 is the interval between the two events, whatever it has been occurred. That is nothing but the delta t. We can write this equation. I hope you are able to see that. And we can write overall delta t. Delta t, which type of delta t is? Delta t is nothing but not here t dash. Change like that. Now we are applying the case 1, case 2, case 3. What will happen when we are applying the different cases? Let us case 1. In case 1, what happened when we are applying case 1? The case 1 explained that delta t dash is greater than, observe equation 4, delta t dash is greater than delta. So we are granting delta t dash is greater than delta. Means the event is occurring, changing is greater compared to the rest position. Then what will happen? We are going to get a delta t dash equal to 1 minus 0. So we are getting delta t is the answer for this equation. Therefore, the time value of light pulse in the frame is equal. Both are equal. Delta t dash and delta t are means the light pulse which is coming from the source and the absorber same at the both at the same time. Case 1. And case 2 what happened? Case 2. Case 2 is little bit different. In case 2 what will get? In case the velocity of what is comparable. Velocity of light is comparable with respect to this. Then delta t dash is greater than delta. And case 3 what will happen? Delta t we are having, but little bit different thing is going to happen in this. What is the is greater than infinity. So it is my imaginary. So what are the different types of frame of reference? I got the time. How the time is getting different. One direction we are getting the one time elapsed. So please note down here some equation. Then we will try to discuss the end part of the calculation. So like this, what we have done, we are able to discuss how the three events are going to happen at a different interval of time. How the time is getting delayed. So orally, the time is a different case. Delta t when the observer is moving, when observer is in a motion, when observers are not at a motion. What is going to happen? So orally, with the mathematical distribution part is another aspect. So orally, what we understand from this time dilation concept is that time is independent of velocity of light. Velocity of light is continuously moving. It does not depend on the time element also. So that is another concept we will can discuss. But here the time is delay for what? For the frame of reference. Depending on the frame of reference, the time is getting delayed. For some object, it will be a slower. For other object, it will be faster depending on that frame of reference. So overall, in today class, we will discuss about the time dilation or time elapsed. The time is getting elapsed. We can understand only when we are taking this is very easy when we are considering plane, flight examples. That's why I am explaining all these examples. But when the particle or an object are moving with the accelerated frame of reference, understood? Suppose the space, gravity, gravity taken into the consideration, what will happen? I will draw a little bit to understand here. So a person is falling down. As the person is moving towards the surface of the earth, as a center, the gravity will move. Here it will fast move. Understood? And whereas here the out of the atmosphere, it is not much because the gravity also plays a very important role in the time dilation. Understood? And depending on the frame of reference, we can see every each and every incident is completely different. Even some examples and some problems also there we can able to understand. Suppose a person moving the spaceship and coming back to the earth because he's moving faster, he will become a younger like that. That is assumptions are there. Though it is not scientifically proved, biologically there will be no changes. It will remain same. Understood? Because we cannot travel near to the velocity of light. Understood? It is impossible to travel velocity because light is the maximum speed it can travel. Due to that, the time is getting delayed. Understood? In this class, we discuss about the definition and background. Also discuss what the background was discussed. In the background, particularly we have discussed about the how the time is getting delayed. Before that, we are taking inertial, non-inertial, and Lorentz transformations, Gaussian transformation, Michelson-Morley experiment, and next we have discussed about the time dilation, definition, concept, and two events we have taken, S and S dash. S is rest position, S dash is moving the constant velocity. And we have taken delta T2 minus T1, how applying the Lorentz transformation, applying we get T2 minus T. Both are cancelled. We are getting this. This is nothing but difference, delta T. Delta T dash is nothing but T2 minus T1 underscore 1 minus V square by it will explain the velocity with respect to the constant and motion. And case 1, 2, 3. And case 1 we can see that the absorbed time with the constant is more greater compared to the velocity of light. And here constant is out of the box. We cannot imagine the delta T is greater than infinity. It is the imaginary constant. So it is a meaningless and considered as a no particular body can move with the velocity of light. So last conclusion is there no body or particle moves with velocity of light. So delta T dash greater than infinity is meaningless. It cannot be greater than infinity. Understood? Velocity of light. Like even if you are sitting on the light also, the light speed will remain same, does not get changed because light speed is light. That is the important concept we should. So it is a very important answer mark for every year. They are asking for our examinations for a short answer. Sometimes they will ask some short answer and they will add that is called what problem. The problem will be added. They will use the what is delta T2 minus T1 and velocities, and we should determine what actual time dilation, how much amount of time dilation is greater the speed, lesser the time. So this is about our today class. Next class we will try to discuss about length contraction. Is it length contraction will definitely will take place? Yes. When the any particle, why we are discussing molecule, a particle is moving. Now we are moving near to the general theory of relativity. Are you trying to understand? Then what happens when the particles are moving very faster and faster, near to the velocity of light, not equal to the velocity of light, where case 3 is speed. When it is moving near to the velocity of light, then it is going to occur. So this is the next class we will discuss it now. Thank you.